Okay, ready? Let's go on and start graphing this one. So we know this is a cardioid. It has the form of a cardioid, right? So we've got A plus B cosine theta. Okay, so this is going to give us a cardioid. So, but what if we don't know what the cardioid is? Well, then we just have to use those steps, right? So find symmetry, right? So again, let's test for symmetry for the theta equal to pi over 2, right? So how do we do that? We substitute in negative r and negative theta. Now the thing is because this is an even function, putting a negative theta in here is just going to give us positive, it's just going to give us cosine theta again. Okay? And then we're going to end up with a negative r over here, and then we're not going to get back to the original equation. So if you just think about it, you can see that we're not going to get back to the original equation, but let's just plug it in anyway. So we get negative r equals 2 plus 2 cosine of the opposite of theta. And of course, cosine of negative theta is equal to cosine theta, so this is going to give us negative r equals 2 plus 2 cosine theta. But then if we multiply through by a negative 1 on both sides, we get r equals negative 2 minus 2 cosine theta, which is definitely not what we started with. Okay? We ended up with the opposite of what we started with. So that didn't work, right? And I said it wasn't going to work. So now let's do the polar axis. Well, that means all we have to do is replace this. And the more you do these, you start to realize that, hey, since cosine is an even number, this is always going to be symmetric with respect to the polar axis, right? Because this side is going to, if we keep doing, well, how do I want to say this? You start to observe certain characteristics when dealing with cosine, okay? Because of the fact that it's an even function versus sine, which is an odd function, okay? But let's go ahead and put this in here. So again, let's test for the polar axis, which means I'm just going to replace theta with negative theta, and I'm just going to keep r the same. And of course, it'll work. So r equals 2 plus 2 cosine opposite of theta. And of course, because this is an even function, we get r equals 2 plus 2 cosine theta. And of course, is the same thing we started with. So voila, this is symmetric with respect to the polar axis. Great. Okay, now, what about the zeros? Where is r equal to 0? So that means we're going to take 2 plus 2 cosine theta equals 0. So now we're going to find out what angle makes this whole thing equal to 0. So I'm going to solve for cosine. Well, if I subtract 2 from both sides and divide by 2, what do I get? I get cosine theta is equal to what? Negative 2 divided by 2, which equals negative 1. Okay, so when is cosine theta equal to negative 1? At what angle does that occur at? Well, we know it's positive 1 when when theta is 0. It becomes negative 1 when theta is equal to pi. Which means when theta is equal to pi, this thing is equal to 0. Okay? Because if this is negative 1, then this makes this 2 times the negative 1, which is negative 2, plus 2, which gives you 0. So there you go. So that means we have a 0 at what? 0 comma pi. Okay. All right, good. Now, what about pi over, well, okay, let's do the maximum value first before we do those, okay? Okay, so what about the maximum value? We want to know what the maximum value occurs. Well, the maximum value occurs when this is at a maximum. This occurs at a maximum when cosine, when theta is 0, right? Because this is at 1 when theta is 0, okay? So what is this? So this is 4, right? So the maximum value of r occurs when theta is 0, right? So and that's going to be at 4 because 1 times 2 is 2 plus 2 is 4. So that's going to be 4 comma 0. Okay, and all I'm doing is just using the characteristics of what I know about the periodic function cosine. So far we've got the maximum value is at 4 comma 0. So let's plot these. So 4 comma 0 is on here. So 4, radius of 4 with an angle of 0. Again, remember this is the polar grid. Okay, this one, it's 0, the radius is 0 at pi. Ooh, so when you're at 180 degrees, it goes to 0. Okay, so it's going through the first quadrant, and then as it's going through the second quadrant, it's getting smaller and smaller and smaller. Okay, and again, if you're thinking the picture and having in your mind what the shape of the cardioid looks like, this makes perfect sense. Okay, but again, if this is your first time going through all this, this is a good practice to go through to solidify it in your mind's eye. Okay, so now I want to know, hey, since we just did 0, we did pi, what about pi over 2? What about 90 degrees? What happens at 90 degrees? So if pi over 2, well, what's the cosine of pi over 2? 0. So this goes to 0. So guess what? I've got another interesting point that I probably want to plot. And that's going to be what? It's going to be 2 comma pi over 2. Because at pi over 2, cosine is 0, which means this term is 0, and I get 2. So now I've got another point, which is right here at 2. Okay, so now, it's from here to here, it's going something like this, right? Or maybe it's doing something like this and coming back down. Most likely because, again, it's probably doing something like this. Okay, I don't know. Let's now make a table. Okay, so I've got those 3 points plotted, so I'm going to erase all this to give myself some more room. Okay, so now let's do the table. Okay, so we got theta r. Okay, so let's I might need another table here, let's do it. I don't know if I'll need it. Okay, so first of all, let's start at 0, right? So 0, pi over 6, pi over 4, and then we got pi over 3, oops, not pi over 2. Pi over 3, and then we got pi over 2, and then after pi over 2, we've got 2 pi over 3, and then we got, 3 pi over 4, and then 5 pi over 6, right? And then we've got pi. Okay? And so now let's plot these points. Okay. So again, 0, right? We already got 0, so that's going to give us 4. And then we've got at pi is 0, right? So pi is 0. And then pi over 2 is 2. Okay, that worked out really nice. Okay, so now, pi over 6. Cosine of pi over 6 is square root of 3 over 2. Okay, so it's square root of 3 over 2 times 2, so this is going to be the square root of 3. So this is going to be 2 plus the square root of 3. Okay, so remember, square root of 3 is approximately 1.73. So just to give you an idea of where we're at. So this is about 3.73. So it's less than 4. So we're going down. Okay, pi over 4, so 45 degrees. Cosine of 45 degrees is square root of 2 over 2 times 2. So this is going to be 2 plus the square root of 2. Okay, right? So again, it's going smaller. Tell it's going smaller. And then 60 degrees. Cosine of 60 degrees is 1/2. So this is going to be 1, so this is going to go to 3. Okay? So again, this is a little bit over 1, so about 1.4. Okay? So again, this is a little over 3, this is at 3, and now we're at 2, right? And then at 2/3 pi, well, now we're in the second quadrant, this is going to be negative, right? So now, this is going to be what? It's going to be 2 minus what? Well, this is 60 degrees. Cosine of 60 degrees is going to be minus 1. Okay, so this was 1 plus 2. This is going to be negative 1 plus 2, which is going to be 1. All right. Now, this is going to be 45-degree angle. So now it's going to be 2 minus the square root of 2. Is that right? Hold on a second. Yeah, that makes sense. And then this one here is going to be 2 minus the square root of 3, and then 0. So again, you could plug these into your calculator and get approximate values. But then what we're going to do is we're going to plot. This takes us the first half, right? So this is going to do something like this. Yeah, so if I imagine, it's going to go something like this. Right? That's the first half. Now we can use symmetry that says, hey, then this is going to be down here at negative 2, right? And so it's going to do something like that. And we're done. And there is our cardioid. Have a great day.